Absolutely. So, couple of things. First of all, homework is due on Monday. Homework's due on Monday, so if you are submitting separate files, that is actually okay. I figured out how to combine them in my PDF viewer, and we are good to go. And I figured out how to grade them online, so I don't have to go to WLC and print them and grade them and scan them and everything else. So yes, and my handwriting is mostly legible. Josh and Grant got their homework back this morning. My handwriting is mostly legible. Yes, okay, I'm getting better at this too. The things I wish I weren't getting better at, but I'm getting better at this. That's the first thing. Second thing, have we talked about when the next test is going to be? I don't remember because I'm losing my mind. No.
Is it the Monday after Easter or like the Tuesday?
No. Friday, the Friday after Easter, Friday, April 17th. I will, one of my goals this weekend is to put the rest of the schedule into a Word doc and send that out to you. But Friday, April 17th is the next test. Friday, April 17th, okay? There is, sorry, one sec, just grabbing my thing. That's also when the second half of the homework from chapter 4 will be due. So the first half of the homework from chapter 4 is due Monday. The second half is due that Monday after Easter. We're just breaking chapter 4 up into 2 homework assignments. Okay, so Friday, April 17th is the next test. Grant and Josh also had the experience of taking a test with me this morning, and it was doable. It worked. It was workable. Okay, they're nodding at you. So we'll do logistics of that, but basic idea is on Zoom, turn on your cameras. I'll make it a little bit shorter. We can decide if we want to start earlier or go longer so that you have time to take pictures and upload it to Moodle and all that fun stuff. But live Zoom test, it seemed to work out okay this morning. So that's my plan there. Any other procedural questions? We'll do homework questions in just a second, but any other procedural questions right now? Anything else? I've given up on dressing up, by the way. Today is Canada shirt, so I am wearing jeans, which apparently is dressed up according to some other people. Some people are living in yoga pants. Daniel.
Was the last homework assignment, is that still part of the thing due Monday?
Correct.
Wednesday.
Yep, so Monday is, I don't have the page numbers, but 4.1, 4.2, and 4.3. That's the stuff due on Monday, 4.1, 4.2, and 4.3.
Okay, thanks.
Okay, good. Any other procedural questions? Like I said, we'll do homework questions in just a sec, but any other procedural questions at this point? Anybody, anything? Okay, anything on homework questions then? Anything on homework questions? No, good, happy, we're good. Nobody's asking me questions. Okay, we'll pretend that's all right. If we finish up class early, I'm not sure if we will, but if we do, you can use that time. I can put you into breakout rooms if you want and can talk about logistics. But again, 2 o'clock on Monday. Homework's due on 2 o'clock. At 2 o'clock. If you get it turned in before class, that's great. Otherwise, 2 o'clock due date. Anything else before we get into section 4.4? Going once, going twice. Okay, section 4.4, we're not going to get all the way through this today. We're going to do about half of it, and then we'll come back and do the other half on Monday. So here we go. Section 4.4 is a couple of different things. The one we're going to talk about today, and for the 850th time, I can't see you all anymore, so raise your hand virtually if you've got questions. Section 4.4 is products, derivatives, and integrals of transforms. Products, derivatives, and integrals of transforms, section 4.4. Remember, products means multiplication. Products, derivatives, and integrals of transforms. So for the probably 6th time this week, Laplace transforms to solve differential equations. The first two steps are easy. Take the Laplace transform of both sides and then solve for capital X of S algebraically. The third step is the hard one, the inverse transform. And so we're trying to get some tools to help us out with inverse transforms. 14th time, that's where we're at. So today, what we want to look at is how to evaluate the Laplace transform of f of t times g of t. Or another way of asking it is the inverse Laplace transform of capital F of S times capital G of S. So we want to look at, if you're multiplying two functions together, how can I do a transform of that? You can't just split it up. And I think I forgot to post my notes online, but I will do that right after class today. I'm sorry. You can't just split it up because the Laplace transforms come from integrals, and we know we can't split the integral up when we're multiplying two functions together. So sadly, we can't just split this up and do it separately like we can when we're doing addition and subtraction. We need another method. So we need a new function. Here's our new function that we're going to deal with. And then we'll talk about how this applies to Laplace transforms in just a second. Our new function is called convolution. All right, and so f of t, our notation for this is star g of t. The way that you read this, I'll tell you how this is defined in just a second. The way that you read this is the convolution of f of t and g of t. That's the way that you read this. So we are doing the convolution of f of t and g of t. This is a new function, so we are going to break out the colon equals. We haven't done that for a little while. And what this turns out to be is the integral from 0 to t of, we're back to taus, f of tau, g of t minus tau, d tau. And this works for t bigger than or equal to 0. Integral from 0 to t, f of tau, g of t minus tau, d tau for t bigger than or equal to 0. The reason that we need the t bigger than or equal to 0 is because of the limits on the integral. We always want to make sure that 0 or t is to the right of 0. Okay, so there's my new function. It's convolution. Here's a cool fact, and this is handy when you are trying to evaluate these. It turns out that the convolution of f of t and g of t is the same as the convolution of g and f. It doesn't matter what order you take the convolution in. You can do it in either order that you want. Either one is fine. Here's why this is helpful. So this fact is helpful because if you look at your convolution function up here, you have to plug a tau into one of the pieces, and you have to plug a t minus tau into the other one. Obviously, that t minus tau is going to be more complicated. So this is helpful because you can plug t minus tau into the less complicated function. You can plug t minus tau into the less complicated function. That's good, that's handy, that's helpful, that makes our life marginally easier. Marginally easier. These things still aren't easy to evaluate, but it's marginally easier that you can pick which function you can plug the t minus tau into. I understand that at this point in time, you have no idea why we possibly care about this for differential equations and Laplace transforms. Hold on for just a minute until I do an example, and then we'll talk about how this is useful to us in chapter 4 with Laplace transforms. But questions on that before we keep going and do an example? You gotta raise your hand virtually if you have questions. Any questions on that before we keep going and do an example? Okay, I'm seeing no virtual hand raises, so let us keep going here. For example, let's say that f of t is equal to t and g of t is equal to e to the at. A is a constant. So where a is a constant. And we want to find the convolution of f of t and g of t. So f of t is t, and g of t is e to the at, where a is a constant. I want to find the convolution of f of t and g of t. I am going to switch you back to full screen mode for just a second because we're going to do a vote. So f of t is t, and g of t is e to the at. All right. Voting for me here, please. Do you want to plug the t minus tau into f, that's number 1, or g, that's number 2? Whatever gets the most votes is what we are doing. You got to be brave. Everybody's got to make a vote. What do we got here? You want to plug it into f, or do you want to plug the t minus tau into g? 1 or 2? Go with what we have. Can't do 3. Okay, everybody's saying 1. All right, let's try it. We'll see what happens. And if that doesn't work, we'll try the other.